So let me tell you a story. It's about a prehistoric cold case, a planet-sized mystery involving a sudden deep freeze, vanished beasts, and a lost human culture. But it's also the story of a scientific idea that was declared dead. I mean, its obituary was literally written, only to come roaring back to life.
What kind of cataclysmic could do all that? For decades, this has been one of the biggest puzzles in Earth science. About 12,800 years ago, something slammed the brakes on a warming planet, wiped out giants like the woolly mammoth, and caused an entire human culture to just vanish. How on earth could one single event connect all of those dots?
Okay, so picture this. 13,000 years ago, the Earth is finally, slowly thawing out from the last great ice age. Things are looking up. And then, bam, the bottom completely drops out. In places like Greenland, the temperature plummets by up to 25 degrees Fahrenheit. It's a shocking, brutal return to ice age conditions that last for over 1,000 years. Scientists have a name for this bizarre deep freeze, the Younger Dryas. So yeah, let's treat this like a proper cold case. First things first, every good detective has to survey the crime scene. We need to understand the full scope of the devastation. And you know, what's just mind-boggling is how many different disasters all seem to hit at the exact same geological moment. You've got the deep freeze, of course, then catastrophic floods from melting ice sheets. At the same time, about 75% of North America's giant animals, mammoths, saber-toothed cats, you name it, they're gone. And then the people. The Clovis culture, known for their incredible spear points, just vanish off the face of the earth. Poof. What could possibly explain it all?
For a really long time, nobody had a good answer. I mean, no single earthly cause seemed to fit the bill. And then, in 2007, a team of scientists pointed the finger at a radical new suspect, one that was literally out of this world.
They called it the Younger Dryas impact hypothesis. The idea is that a comet, or maybe a bunch of fragments of a comet, either slammed into the Earth or exploded in the atmosphere. The result? Total chaos. Continents spanning wildfires, a huge cloud of dust blocking out the sun. That, they argued, is what triggered the cooling, the extinctions, and the collapse of the Clovis people.
And look, this wasn't just some wild theory they pulled out of thin air. They had receipts. They found this layer in the dirt right at that 12,800-year mark. It was full of tiny melted spheres, microscopic diamonds forged under intense pressure, tons of soot from massive fires, and even a spike in iridium, a metal that's way more common in asteroids than on Earth. I mean, it really looked like they had their culprit. Seemed like an open and shut case, right?
Well, this is science we're talking about. And in science, an extraordinary claim needs extraordinary proof. Almost immediately, the scientific community pushed back, and they pushed back hard. This whole idea was about to be put on trial.
The critics basically said, hold on a second. They argued that, yeah, the claim is huge, but the evidence? Not so much. They suggested that all those markers could be explained by, normal stuff that happens on Earth, or maybe even just the slow, steady rain of dust from space.
And then came what seemed to be the killer blow. It all came down to replicability. That's the absolute bedrock of science. If other people can't repeat your experiment and get the same results, you're in big trouble. So a different team went back to the key sites to check. Their findings? Absolutely devastating. At one spot where the first team found nearly 100 microspherules per kilogram of dirt, this new team found nothing. Zilch. Zero. And that was pretty much it. Case closed. In 2011, a major paper came out that was literally titled a requiem, like a funeral song for the hypothesis. It was called a cautionary tale, basically bad science. The Younger Dryas impact hypothesis was officially dead and buried. But, like any good cold case, this one had a twist. A few persistent scientists just couldn't let it go. Something didn't feel right. So, they decided to investigate the investigators. They took a hard look at the methods the debunkers had used. And they started asking this really simple but brilliant question. What if the evidence was there the whole time and the debunkers just missed it? What if they were looking for it in the wrong way? And the answer they got back was just, wow, absolutely stunning. In 2012, a new blind investigation went back to the exact same spots, and what did they find? Microspherules everywhere. Get this, at the site where the other team found zero, this new team found a peak of 317 per kilogram, even more than the original team, the evidence was there all along. So you gotta be asking, how is that even possible? How can one team find nothing and the next find a treasure trove? Well, it turns out the debunkers' methods were just flawed. Their sample slices were too thick, which basically watered down the evidence. Their samples were also way too small to have a good chance of finding anything. And, this is the big one, they weren't using the right kind of analysis to tell an impact spherule from a regular speck of dirt. So it was never a case of no evidence. It was a case of bad methodology. And once that dam broke, the evidence started pouring in. I'm talking a flood. Today, researchers estimate that a staggering 10 million tons of these impact spherules rained down across at least 4 continents, all at that one precise moment in time. Okay, so the evidence is mounting. But to really close this case, to convince every last skeptic, they needed that one final, irrefutable piece of evidence. They needed the smoking gun. You've probably heard about the asteroid that killed the dinosaurs, right? The big clue for that was a thin layer of a rare metal called iridium. Well, platinum is in that same family of metals. It's another one of these telltale fingerprints from space. You just don't find much of it naturally in Earth's crust. And in 2013, they found it. Scientists looked deep into the Greenland ice sheet, which is like this perfect frozen timeline of the atmosphere. And boom, right at the start of the Younger Dryas, platinum levels suddenly go through the roof, 100 times higher than normal. And then, just as quickly as they appeared, they're gone. That was the smoking gun. This wasn't just any old piece of data. It was so powerful, it actually converted one of the world's leading climate scientists and a major skeptic of the theory, Wallace Broecker. After he saw the platinum data, he basically said, "Okay, you got me. An impact happened, and I now think it's what triggered the Younger Dryas." When you flip a top mine like that, you know you're onto something big. So, wow, what a ride, right? From discovery to rejection to this incredible comeback. Where does that leave us today? Has this thing graduated from being just a hypothesis? Well, the evidence today is just a mountain. It's global. From sites in California to Chile, from Syria to South Africa, scientists are finding the exact same suite of impact markers. The spherules, the nanodiamonds, the soot, and that all-important platinum spike, all locked in that same thin layer of dirt, dating to precisely 12,800 years ago. You know, this whole story is just a fantastic lesson in how science actually works. It isn't some clean, perfect march to the truth. It's messy, it's human, people argue, they make mistakes, they go down the wrong path. But the beautiful thing about science, its greatest strength, is that it is designed to fix itself. Sooner or later, the evidence wins. So that leaves us with one final, pretty provocative thought. Remember, this idea wasn't just dismissed. It was ridiculed. It was declared dead. Its revival is a testament to just a few persistent people. And it makes you wonder, doesn't it? If an idea with this much evidence behind it could be buried for years, what other revolutionary, dead theories are just sitting out there, waiting for a second look?